Good day, students, and welcome. Okay, good day, students. Welcome to the Metric Hub channel. And today, as you can see, we will be doing, and quickly fix the pen. Yes, today we will be doing social science grade 8, but we'll be focusing on geography, the geography side. All right. So if you look at the instructions, it says, please number all questions and they are numbered on the question paper, meaning each question should be as is. So if you're going to answer 1, you're going to say 1, 1.1.1, 1.1.2, 1.1.3. Secondly, it says calculators may be used. It means that you may go into the test or the exam room with your calculator. And then the last one, no correction fluid may be used. What they mean by correction fluid, they're talking about a T-PEX, your T-PEX. So don't use a T-PEX. Rule a neat line through any error. So if you made a mistake, let's say, for instance, you say, Hoto. If you made a mistake, you just rule a line there to show that it's a mistake. Ne? So without wasting any further time, let's get into it. Without wasting any further time, let's get into it. So, question one. Question one states, it goes as, state whether the following statements are true or false. So here you're going to write, for example, you're going to write 1, then you're going to say 1.1, whether it's true or false, whether it's true or false. All right. So state whether the following statements are true or false. Only write down the question number and the answer. Here they even showed it to you. They even showed it to you. 1.6 false. Or if it was true, we're gonna say 1.6 true. All right. All right. So I'm just looking for, let's just see. Okay, let's see. Okay, let's scratch that one. Okay, let's go back to the questions. All right. Let's go back to the questions. So what does the question says? Question 1.1. It says climate is the atmospheric conditions. Atmospheric conditions at a particular place and time. All right. So it says climate is the atmospheric condition. So what is atmospheric? What is an atmospheric condition? All right. So firstly, let's explain what an atmospheric condition is. Right. So what is an atmospheric condition? So what do they mean by an atmospheric condition? So an atmospheric condition is a state of the atmosphere at a particular place and time. So by saying this, what we mean is that, so it's a what? It's a state. What do we mean by state? The temperature of it. We're talking about the temperature of it. We're talking about the humidity, how moist it is, right? And maybe lastly, the what? The cloud coverage. How are the clouds? When you look at the sky, is it a dark gray sky or is it an open sky? Ne? So that state will tell you in terms of the temperature, the humidity, and the cloud coverage. Right. So they say atmospheric condition is a state of the atmosphere. So at that particular point in time, the atmosphere might be at a high temperature, or it might be moist, or there might be cloud coverage. At a what? At a particular time. At a particular time or place. So meaning, let's say on a Tuesday, the weather was, for example, on a Tuesday, the weather was 45 degrees Celsius and it was moist with no clouds. So that would be your what? Your atmospheric condition. So this will be your what? Your atmospheric condition. So when we go back to the question, rather, the question, it says climate is the atmospheric conditions at a particular place and time. And we just explained what an atmospheric condition is. So basically, it tells you that it is not based on the description that I've just given you of atmospheric condition. It shows that climate is not the atmospheric condition. Because what is an atmospheric condition? It's a state, not climate. It's a state. Ne? At a particular point in time where it has a certain number of temperature, it is humid or not, or there is cloud coverage, right? So as they further explain it, they say weather is the atmospheric condition at a specific place and time, not climate, weather. So weather now becomes the what? Weather is the what? The atmospheric condition. Weather is the atmospheric. Now, as I explained it to you, here is your weather. So, for instance, in the news, they'll give you that 45 degrees. This is your what? Your weather. This becomes now your weather. So, weather is the atmospheric condition at a what? At a particular time or place. So, what does climate refer to now? Now that we know what an atmospheric condition is and so forth. So, what does climate refer to? Since, well, the statement is what is false. What does climate refer to? So climate refers to the long term average. Long term average. Long term average of weather conditions. So now, okay, let me just say, okay, I wanted this, but okay, we'll go back to it. What long-term average of weather conditions, right? So what that means is that within a period of time, so let's say weather happens in one day, on a Tuesday, weather can be an atmospheric condition on a Tuesday. But as soon as it becomes for a long period of time, for a long period of time. So if weather or when weather becomes an atmospheric condition over a long period of time, then it becomes the climate of that particular place. So it's a long-term average of weather conditions in a place and time over a long period of time. So within time, then your weather will become your climate. Let's say, for instance, as I said here on a Tuesday, now this becomes your weather. But now let's say it's on a Tuesday, Wednesday, Thursday, up for at least say 10 years or 20 years. Now that becomes your what? Your climate. So climate is weather over a long period of time. So here when you look at 1.1, climate is not the atmospheric conditions at a particular place and time. So weather will become your atmospheric condition at a particular place and time. All right. So that will be your what? That will be your. So I just wanna erase here. Okay. No, 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 no. All right. So that will become your what? Your weather. Uh, I'm not sure how to. Let's see. Let's just do here. Let's go pause and let's go back here. I found it. This is what I wanted. Okay, so now remember that climate is not the atmospheric condition, weather is, right? So let's move on to the next question. Let's move on to the next question. 1.2, it says cities on the equator have the greatest temperature range. So what they mean by temperature range, we mean by the maximum and the minimum temperature. So remember that weather has a maximum and a minimum weather. All right. So I just want to quickly get over with this. Let's quickly get, yes, yes. So bear with me. So it says cities on the equator have the greatest temperature ranges. So I just want to show you what they mean by a temperature rather range, right? Yes, okay. Okay, all right. Okay, let's go back. So we're done with 1.1. So let's move on to 1.2. 1.2. So remember in weather we have a maximum and a minimum. So this will be say in the afternoon or in the morning, and this will be in the evening, right? So they say here, cities on the equator have the greatest temperature range. So we want to see the difference. Let's say this one it's 45 degrees to 15 degrees. So this is what we call now the temperature range. It ranges from 45 to 15, how much it drops or how much it rises. So you need to remember that in the equator, that's where it's so what is the equator? Let's first start there. What is the equator? So the equator, right? The equator is what? So the equator is that imaginary line that runs around the middle of the earth. So if you look at your earth, let's say this is the earth, right, as a circle, and this will be Africa, this will be your Europe, your Russia, your Asia, your countries. Ne? So an equator would be a line now that goes through the middle. It's an imaginary line. You can't see it, right? And it places near and at so for places near and at the equator, they receive sunlight directly. So what that means is that if for instance you see here's say Africa here, let's say it's Egypt. So places near Egypt will do what? Will receive sunlight directly. So for places near the equator, sunlight goes to them directly because they are at the middle of the earth. So cities near the equator usually have very small temperature ranges because the sun shines directly. So at the equator, so let's first start there. So remember, an equator is an imaginary line that runs, let's say through or around, okay, let's say around the earth, right? So you can't see that line. And so remember for places near the equator, for places near the equator, what happens? What happens for places near the equator? Sun shines directly. The sun shines directly, right? So if the sun shines directly, it means that there is less of this, of that, what, of the range. Because now here we're talking about 45 degrees, so it's too hot. And then when we go back to 15 degrees, it's much less hot. Say now it's starting to become coldish. So when we talk about the range, we talk about how hot is it in the morning and how cold is it in the evening. But for places and cities near the equator, it's not necessarily more hot or more cold. So it's rather at a very stable range. So what we now gather is that for cities near the equator, what happens? What happens for cities near the equator? What happens? So the range is not it's not that great. You see, it's not the greatest temperature range, meaning it's not a huge number of because of what? Remember the sun. So the sun can shine. Maybe let's say in the morning it's too hot. Even in the afternoon, it might be that hot. Even in the evening, it's not like a place whereby it gets hot in the morning and then it gets so cold in the evening. So for cities or for places near the equator, it's rather more at a very same range, right? So this will be what? Will be false. So it should have said cities on the equator have the uh, the minimum temperature range. It has the minimum, not the greatest, but the minimum. So cities near the equator have minimum, right? It has minimum temperature rate. So for cities near the equator, it has a minimum. So for places further from the equator, they have those are the ones that have the greater ranges. So here you'll say, I'll just say, so here, okay. So here you'll say places further. Places further from the what? From the equator. They are the ones with the greatest temperature, or rather temperature rate or range. Ne? So if you live far away, remember this is your what? This is your equator, right? That imaginary line. This is your equator. So for everyone who lives near here, they'll be, or they'll rather have a minimum temperature range. But for places like here, South Africa, we'll have what? Rather a great temperature range. All right. So here it's false. So cities on the equator have the greatest temperature range. It's false. All right. And then moving on to 1.3. Let's quickly move on to. Guys, please don't forget to like, share, and subscribe and follow so that you don't miss out on other videos. And please don't skip the video or move on to the next chapter because we go question by question. So you need to understand the questions as we go with them. All right. You need to understand the questions as we go with them. So let's go to 1.3. So we're done with 1.2, we go to 1.3. 1.3 says, Cape Town is the Mediterranean climate region. So it says Cape Town is the Mediterranean climate region. So what is a Mediterranean city or place? A Mediterranean city or place. What is a Mediterranean city or place? So these are cities that have climates with mild and wet winters and with also warm to hot, dry summers. So what happens? So a city or a climate that is of a Mediterranean, it means that in winter, what happens? Let's say it's moist, mild, and wet. So there will be more rain. There will be more rain in a Mediterranean place or city. There will be more rain, and there will be more water or wetness from the sky. Remember, let's say temperature forming from the clouds. So there will be more water in winter. But what happens then in summer? In summer, there will be what? There will be hot but dry summer. So the summer will be hot and dry, meaning there will be less, it will be less timid or humid per se. It will be less humid because there will be less water. So it will be a dry. So that the summer will be too hot to experience moist and what and wetness. Right. So that is what they mean by a Mediterranean city or place. So what is the question? Right. So the question says that Cape Town is in the Mediterranean climate region. So wherever Cape Town is situated, it means that in winter there is moist, there's mild, and there's wet rain. And then in summer, it's very hot and dry. So that is what they mean. And looking at a place like Cape Town, if you know Cape Town or having to have studied about Cape Town, this now becomes true. Because in Cape Town, in winter, it becomes very wet. So there's a lot of rain and it's very cold and more, not necessarily snow, but there's more rain and there's more moist, meaning there's humid around the area. All right. So this usually happens where in the Eastern Cape. So in the not rather eastern, the western, in the western regions, it becomes hot, dry in summer, but also cool, meaning there's more breeze and wet. There's more rain in what? In winter. So as I say, if you've studied these regions, maybe in grade, say 6 or 7, you'll know that in the western areas, in South Africa, most probably in the western regions, you'll find that the summers are very hot and dry, and then the winters are very cool, moist, mild, and they are wet. So we go back to the question. Cape Town is in the Mediterranean climate region. The answer is true. All right. The answer is what? It's true. And then now we go to 1.4. We go to what? 1.4. Firstly, let's erase 1. So guys, remember the Mediterranean, it becomes moist, mild, and wet in winter and hot and dry in summer. So that's what happens in Cape Town. All right. So that's what usually happens in Cape Town, or rather in the western regions. We talk about places like Stellenbosch, your places in the western provinces of the country. That's where you find Cape Town. All right. And then now we move on to 1.4. 1.4. Normally, south-facing slopes get the most sun in the northern hemisphere. Guys, remember when we were talking about the Earth? So I want you to go back and then remember this is your what? This is your what? Yes, it's your equator. This is your equator. And then now this becomes your northern hemisphere. This becomes your northern hemisphere. This becomes your southern hemisphere. And remember, how does the sun shines? It's shone like this to the equator. That's why, that's why that's why places in the equator, they do what? They have the minimum temperature ranges. So it will range from, say, 45 degrees to 40 degrees. It wouldn't be a great temperature range. So remember this, the sun shines directly to the, so in the north hemisphere, the sun will shine down. In the south hemisphere, the sun will shine up. So they say normally south facing slope. So what is a slope? Firstly, let's start there. So what are slopes? When we talk about slopes, what are we talking about? All right. When we talk about slopes, so when we talk about slopes, we talk about uh, things like your hills. So a hill will be a small mountain, or rather, I don't want to say climbable mountain, but it's a not a very steep, but rather a very seen mountain. And then when we talk about slopes, we talk about again your what? Your mountains. It could be your table mountains. And then lastly, your what? Your valleys. So this is what we talk about when we talk about your slopes. So when they say normally south facing slopes get the most sun in the northern hemisphere, what do they mean? It means in the northern hemisphere, you'll find that your mountains will be facing so. So remember, how does the sun rather shines? Okay, firstly, let's go. Let's rather explain this in a more fashionable way. In the northern hemisphere, remember that south-facing slope, they receive more direct sunlight since the sun is mostly in the southern sky. You see, it's in the southern. So where's the southern sky? Here's the southern sky. So if the sun shines this way and your slopes are put in your north hemisphere, your slopes are put here. So you see, the slopes will receive what? Direct sunlight. All right? Because what they're facing, what? They're here, they say south facing. So what do we mean by south? South, north. So south is down, north is up. So south facing. So these slopes are facing downward. And why do they get? Because they're situated in the northern hemisphere. Why do they get more sunlight? It's because in the southern hemisphere, your sun shines directly to the equator. Remember, to the equator. Now it becomes direct to those what you call the slopes. So you understand. So if they are south facing and they're facing in the what? In the southern hemisphere, it means that the sun shining from the southern hemisphere to the equator, it hits directly your slope. So normally south facing slopes get the most sun in the northern hemisphere, and the answer will be true. Your answer will be true. All right. So there you have it, 1.4. Your answer will be true. And then let's go to 1.5. Let's quickly go back to, or rather, let's go to 1.5. All right. So, guys, don't forget to write your answers. It's false, false, true, and true. Ne? Again, let's go to 1.5. So, 1.5, what does the question say? So, 1.5, what does the question say? All right. So, the question states as the Himalayas funnel cold air into India. So what it means that the Himalayas, it gives. So funnel, it's a synonym for gives or provides or provides. So what they're actually asking is that does the Himalayas give or provide cold air into India? So firstly, what we want to know is what are the Himalayas, or what is the that is spelled incorrectly. What is the Himalayas? Right? The Himalayas. Yes. So what is the Himalayas? So The Himalayas is a vast of mountain ranges, meaning like when you look at your skyscrapers and you see that the skyline, so the line that shows different mountains that are combined together. So the Himalayas is a vast, meaning uh combined combined mountain mountain ranges in Asia. So let's say when you look at Asia, saying you look at countries like China, not necessarily only China, but the combination of all mountains within Asia. That's what we call the Himalayas. All right. So it's a vast mountain range, or rather compound of mountain ranges in Asia that is formed by various mountains, formed by various different various mountains. All right. And these mountains may include one, the Mount Everest, the most famous Mount Everest, the coldest mountain probably in the world. Number two, a mountain called the K2. And thirdly, the Annapurna Mountain. So if you research properly and you go back to your books, you might have studied about the K2 mountain and the Annapurna mountain. So obviously, in terms of general knowledge, I'm sure that the Mount Everest is the most common mountain that you might know. So the Himalayas is a vast a combination of mountain that ranges in Asia. It is formed by very different mountains, your Mount Everest, your K2, and your Annapurna. So let's go back. All right. So before we go further, you need to know that the Himalayas actually acts as a barrier and it blocks cold winds from Central Asia from entering India. So what happens is that uh, let's say, okay, let's India, all right, and remember what is a Himalayas? It's a combination of mountain that form the range, all right? So these will be your mountain. This will be your Mount Everest. So it's just an example, right? Let's just say EG, and then this will be your K2 mountain, and then this is your Annapurna mountain, right? And this side, it's what? It's AG. So what you need to realize here is that the Himalayas act as a what? As a blockage, meaning it blocks the wind from going to India, or rather from entering India. So you see the ranges and how they range. So these three mountains will block cold winds from entering India. So when we go back to the question, the Himalayas funnels or gives or provides cold air into India, and then your answer will be false. No, because why? It blocks. It acts as a blockage. It doesn't funnel, it doesn't provide, but rather it blocks. All right. So that is your answers from 1.1 up to 1.5. All right. Those are your answers from 1.1 to 1.5. All right. So, guys, please stay tuned in our next video as we will be doing question 2 to 4.2. So, in the next video, we'll be focusing on question 2 to question 4.2. So, stay tuned and watch more videos. So, remember, this is grade 8. I'm just going to put it there for you. This is grade 8, social science. This is grade 8, social science. Grade 8, social sciences. But here we're focusing on the what? On the geography side. The geography side. So guys, please stay tuned for more for question 2 So in the next video, we'll be doing question 2, question 3, and then question 4. We'll be doing question 2, 3, and 4. Obviously combining 4.1 and 4.2. So thank you for tuning in and see you again.